Hello everybody. Good morning. Welcome to the fifth ETP4HPC webinar. I'm Pascal. I'm ETP4HPC's communication manager, but there are other members of our team present to help. Maike here is taking care of the chat, so she's the one who is chatting to you. And well, Sai and Jean-Philippe are both, you can see them, they are both members of the ETP4HPC team, and they have organized today's webinar. So before we really start, I will give you a couple of practical information. So you have probably noticed that this webinar is in listen-only mode. It's recorded, and you will receive the link to the recording. I think it's tomorrow. You will receive an email. So on your computer desktop, you should see on the right-hand side the GoToWebinar control panel that's illustrated here. And you can use it to ask questions. I mean, you're muted, but you can ask questions. So please use the question panel. You can send your questions at any time during the webinar. I will answer them online whenever I can, and we'll keep the global questions for the end of the webinar for the discussion time. You can also download handouts from this GoToWebinar panel. If you unfold the handout section, you will see that we have put 5 handouts for you today. So you can download the presentations, the 4 presentations. And I have also put the copy of our Handbook of European HPC Projects. It's our latest publication, very interesting, not really related to today's presentation, but as I said, it was published only a few days ago. So I hope you'll enjoy it. So while we look at today's agenda, for those of you who are not familiar with ETP4HPC, I would just like to introduce our association very briefly. So ETP4HPC is a non-profit association that promotes European research and innovation in high-performance computing, HPC. So we are a private member of the EuroHPC JU. You probably heard of it. That's the, well, to put it simple, that's the organization in the European Commission that addresses HPC. And so we propose to EuroHPC research priorities for Europe in the area of HPC, that is the research areas that should be funded. So, well, I have finished for today. Now I hand over to Sai, our VP Industry, for an introduction to this webinar. Sai?
Hello, yeah. Can you hear me all right, Pascal?
Floor is yours. Yes.
Great. So, yeah, really nice to be here today. So my name is Sai Narsimurthy. So I'm the VP of Industry for ETP4HPC, and I'm also a coordinator for the Industry User Work Group. So I'm really pleased to be here today with my ETP colleagues and also my colleague Jean-Philippe. So if you just go to the next slide, Pascal. Thank you. So just to give you a quick introduction and motivation, I don't want to take a lot of your time because we want to quickly go to the discussions. So the industrial use of HPC is a very major pillar, as you know, for the European HPC strategy. And there's a lot of work on getting academic communities to use HPC, but the industrial use of big supercomputers, HPC machines, it's still work in progress. So what we did was about a year and a half back, we set up the industrial user working group within the ETP4HPC, and the goal was to have a deeper understanding of the needs of industrial users. And what we all recognized was that ETP4HPC is a very strong conduit between the industrial users as well as EuroHPC as well. And that's a feedback that we got from the commission, that ETP4HPC should be is in a very very nice position to actually bridge some of the gaps in understanding of the needs of industrial users. And we all know that the big EuroHPC machines are going to be coming up soon. and we want the commission wants the industrial players to start using those machines, and we want the industrial users to contribute to the research and innovation agenda as well. So it's a very good timing, timing-wise, for us to start conversations with the industrial users and understand your requirements. And we want to start addressing the industrial user requirements into future research and innovation agenda as well. So that's a quick introduction for why we are doing all these activities with the industrial users. And the goals for today is to start understanding looking at some HPC usage examples of how some of the industry is already exploiting HPC. So we will look at different sectors that are represented by our friends from Seekos, Leonardo, Uberism, and Repsol. And then we can have a deeper discussions on what are their pain points, what are their challenges, and we are very much all ears. And we also look forward to the discussion as well. So Pascal, if I can request you to go to the next slide. So I think Pascal has just covered this. So we'll have a quick introduction from Dr. Carlo Cavazzoni. So we would like to welcome them as part of ETP. And then, so welcome to our welcome to the ETP and part of the Industrial User Working Group, Carlo. So I would like to just welcome you. And then Pascal, I think we can start going through the introduction from Leonardo, and then the individual, just a quick brief about HPC usage from the different speakers, and then we can quickly get into the discussion. And we have prepared some questions for the panelists, but we really want the audience to be active in asking questions as well. This is a great opportunity, so welcome everyone.
So remember,
Pascal,
question pane. Okay, so Carlo, I'm handing over to you.
Viro,
Yeah,
ven rápido.
Please, yeah.
Good.
Okay.
Go ahead.
Can you hear me? Yes.
Yes.
Thank you for the invitation. And actually, I've been part of the family since many years, but with a different role. So I was part of, let's say, of ETP4HPC from the academic institution side or research institution side, being part of Cineca. But now this year, I started a new, let's say, job and a new, let's say, journey, okay, technological journey. And this probably is the best, example on how now company or tech company are investing in high performance computing, because they came and looked for me, for my competence, in order to set up an high performance computing lab, which now I'm head of in Leonardo. Leonardo is an high-tech company mainly focused on aerospace, defense, cybersecurity, and now opening up also the business to new segment. Leonardo has more or less 50,000 employees, and the annual turnover is about 14 billion euro. Okay, this is the size of the company, and the company understand that now, in order to keep the pace with the digital transformation and not only digital transformation, but also to keep the pace with the new value coming from new component like artificial intelligence that enter into the devices we produce, so helicopter, planes, and the like. It's important to invest in high performance computing, because this is where you can have the sovereignty of this technology and master them, okay, and attract people to work on internal IP rather than only buying intellectual property from outside. Just said that, so the lab, the Leonardo lab, which is the company new structure is being set up in those days, and part of the labs there are 6 structures on different technology key component, and I'm the responsible for high performance computing, applied artificial intelligence, and big data. And the lab will be located in Genova, and a difference with let's say other institution or other company, we decide to have everything in-house to build the facility for doing the research. So we have installed a supercomputer, which is actually the 89th of the last test top 500, which more or less 5 petaflop of peak performance. We have a data repository and for managing big data, and obviously we will have we are refurbishing a building here in Genova, which will be the headquarters of the lab with up to hundreds of researchers. We will start with more or less 70 researchers at the beginning of the next year, and we have we have the plan to grow up to few hundreds, mainly involved in the 3 legs. So HPC specific for traditional, I would say, HPC, artificial intelligence, and big data technology. I have to say that we have in our vision the convergence of the three buzzwords, if you want, because every day is more and more difficult to have distinction between the three pillars. So because of those that have to make AI application need HPC to perform hyperparameter optimization if they want to have original solution, not to just to work on let's say public data lakes and public topology. Key enabling technology for the lab will be from the point of view of the hardware, HPC, cloud, IoT, and edge, because the company product include drones and autonomous objects, and so edge and IoT will be, let's say, in our range, and we are going to set up also an edge, a lab, a small part of the lab for edge related application. From the point of view of software, simulation, artificial intelligence, big data analytics, and digital twin will be among our portfolio and the activity where researchers will be engaged. So our paradigm, I would say, is represented in the following in this slide, where we see more and more a convergence about HPC and cloud resources. So we internally will provision let's say the HPC resources in 2 ways. So traditional batch-like access to the machine, but also, especially for big data application and artificial intelligence, we will provision the resources to the engineers of the company and to the researcher using a cloud stack, in particular based on OpenStack, and we will deliver the resources as a virtualized environment. Then, as I said, we are interested also in Internet of Things, because many of the goods the electronic division is producing is closely related to Internet of Things, and edge computing, because we also develop digital setups or let's say component technology component deployable on different mission scenario, and at the end there is the user in our view. So summarizing, the idea is to build with the lab a path from the starting from model and data. So data collected from a sensor mainly, or from other sources that can be also open data collected from the web, or we have also let's say in the company we have access, and actually we are also building sensor from satellite, and we have access to some satellite constellation data, and so we have also observation from above of the Earth, on which we would like also to develop new business and new services. But beside that, so we start from models and data, and we will use a convergent solution, including HPC and cloud, on the same facility to do two things: so simulation and digital twin, and train AI model, essentially to make prediction about, just to make an example, maintenance procedure of helicopters. And just to give you a few examples, we would like to exploit the GPU, in example we have in the machine, to perform quasi real-time simulation of helicopters and build digital twin. This is essential for designer of helicopter in order to, let's say, have a quick answer on change they can make to the design of the helicopter itself. Or another, as I said before, quickly anticipating before, collect a lot of data from again the fleet of helicopter we have on customer premises, and provide additional services, so added value services like predictive maintenance, or let's say giving advice on how to better use the machine in terms to save fuel, in example, or to use the different routes when performing their mission on a day-by-day job. Then, last but not least, we will use the facility to enhance the training of neural network. We are developing a lot of technology, and we will need to develop a lot of technology for our surveillance business, in which we would like to do a lot of image processing, in example, to control, also for civil application, to control the distance between people, or to ensure that people do not get too close together, or to get too close to a dangerous machine. Okay, in example, we have several already working setups in metros in Italy that checks if people do not follow on the railway from the seaside to the railway. And finally, another problem is to work on trusted AI, because before introducing neural networks and artificial intelligence component on planes or helicopter, there is a rigid procedure for certification of what is flying, and we need to ensure that what we install on planes and helicopters, especially if those can do autonomous maneuver of the helicopters, are safe enough to pass the certification. And for that, we need sort of to ensure that the component based on artificial intelligence do not produce unexpected results, and this mean become trusted for the certification. And I think this is all for my introduction.
Thank you.
Thank you, Carlo. Thank you very much. It's very insightful to see that you address so many areas. You're starting to address AI quite seriously. Thank you so much.
Thank you. So I don't see any questions coming in, so please remember that you can ask your questions anytime. And now we hand over to Kanta.
Okay, give me a second. I'm just sharing my, okay. I think you can see my
Yeah,
screen.
yeah.
Okay. Hello, good morning, buenos dias. Thank you very much for this opportunity. So you can see that there is a very long name, so it'll make your life easy. You can call me Kanta, as Pascal has already introduced me. Okay, so don't have to worry about the big name. Okay, so I work as a senior portfolio manager in Repsol Technology Lab. Okay, so if I have to give a very quick and brief introduction about who we are, and then what is our objectives, I will start with four very unique points. So the first most important thing is a talented team. Repsol has got around 25,000 employees across 34 countries. Okay, so that's the main human talent asset. Then a firm commitment to innovation, research and innovation, and then we have a societal obligation, and then as a company we have set up this net zero emissions, and then we define ourselves as a global multi-energy company. So as you can see that Repsol is the first company in the sector of this energy, especially in oil and gas, to announce that we want to become a net zero company by 2050. Okay, net zero emissions by 2050. This is a very top-down strategy, starting from our chairman, our CEO, and that is going to the last person standing operating in a refinery or in an oil platform. Okay, with this background, I will give you a brief overview. Okay, I'm not covering the different business segments internal in Repsol as a multi-energy company. So the views that I'm going to express is from the perspective of upstream, that is exploration and production. So I'll be just giving you a brief introduction. Where do we need, or where we are already using or exploiting HPC? So the areas which I'm going to cover very briefly is related to geophysics, geology, geomechanics, petrophysics, reservoir engineering, and finally production engineering. Okay, if you can see here, the geophysics has got the value chain. In a sense, it has got four important areas. One is the design and acquisition of the geophysical data. The second one is the processing of that one. Third one, you're going to do imaging, and then finally you're going to do the interpretations. Okay, so from that perspective, this is, as I explained, you can see that at the end of the day, we want to have a positive, recognition of the hydrocarbon deposits. Okay, and then we need to, or we should be able to trace a well trajectory safely, and then we should be able to drill that safe trajectory without any risks. And then if we have any risks, then we should be able to mitigate them. So the planning is very important. As you can see that this particular task needs, starting from acquisition design till the interpretation, it's heavily uses high performance computing. Okay, so basically they use both the CPUs and GPUs, hybrid cores. Okay, so that's how they are all the different tools that are used here. Repsol has got several of these tools developed. So I just want to mention here that Barcelona Supercomputing Center is the one of our principal main, I should say, partners in research and innovation. Okay. So moving on, so you can see what exactly HPC can do in geology or in geomechanics and petrophysics. Just to give you an example, imagine a piece of rock that's maybe a shale rock from unconventional reservoir, and then these have the pore size of nanometers. So if we want to assess the pore size capacity, how the hydrocarbons or the fluids are going to move internally there, then we might end up having experiments done for several months, sometimes 6, 8, 7, 9 months to have complete saturation, and then find out the properties. Instead of that, you can use the medical grade or even better CT scans, high resolution electron microscopes, SEM, FIB-SEM, all these images, and then you convert these images into mesh, and then you will be able to do something called digital petrophysics for reservoir characterization. So imagine that you're going to have a millimeter scale representation of that rock sample, and then you can get the results in terms of weeks instead of months or several months. So that's one. And then you have a geomechanical modeling, where you're going to have the full scale model of a field. A field can be 15 kilometers by 30 kilometers, in the super surface, and then it can be of several hundreds of meters thick. But that is located below 3 or 4 kilometers below, or sometimes 6, 7 kilometers below the surface, or the surface of water, or the ocean bottom. So then you need to have this complete full-scale model done for this reservoir characterization from the geomechanical perspective. So this can be easily 20, 30, 40 million size calculations that you need to do. These are all quite not one-time calculations. You have to do several, and then throughout the reservoir life cycle can be sometimes several decades, and then you are extracting hydrocarbon as you go. Okay, so basically you're looking at the coupled thermo-hydro-mechanical behavior and using finite element methods. Okay. And next, if I move to reservoir engineering, there are two things. Reservoir engineering, you have the traditional reservoir simulators. They use these traditional reservoir simulators. They are basically I should say fluid and thermo fluid. So these are multi-phase fluids. Okay, so we will have hydrocarbon as liquid, hydrocarbon as gas, hydrocarbon as condensate, and then we also have water there in a porous media. Okay, and then temperature effects is there. You know that PVT, pressure, volume, temperature affects all these hydrocarbons, and this is a complete multi-physics problem. And once again, this can go for several decades. So sometimes the simulations. Okay, that's the time frame we have then. And additionally, we are looking into, this is the traditional way of using the HPC. Additionally, we are looking into advanced data analytics, okay, optimization of field development plans. Imagine that you have one field development plan that needs to be optimized. It has got anywhere between a minimum of 40 million to maximum of 400 million investment that is going to happen over 5-6 years. Okay, so for this, you need to have an optimized plan when you're going to drill the next well, where you're going to drill the next well, why you need to drill this next well, if it is a production well, if it is injection well. So these are all several multi-objective optimization. We need to do this. So then we have to see, these are all very capital intensive projects that needs to be optimized to the last, and then this optimization needs to have over during the execution. Okay, once again, the end goal is risk analysis and decision making process. So that's the main. So you are looking anywhere around between 300 to 400 simulations every month. That might take sometimes an hour to 3 hours. Okay, so if we are looking from a machine learning or artificial intelligence perspective, so these simulations can be reduced to sometimes seconds. That will allow for the real-time decision making. Once again, HPC is going to play a very important role. It's already playing a very important role there. Finally, I just want to touch based on production engineering, where you got something called flow assurance and risk prevention. This is very important, where you are going to have a wellhead several, sometimes hundreds to several kilometers of water height. And then you have complete installations of these facilities. This is called midstream, from the wellhead to the place where you're going to use this hydrocarbon loaded to go to a refinery. So this is these installations where you need to secure that the flow happens without any risks. Okay, once again, this is basically computational fluid dynamics. Okay, and then you also need to have simulations once again, this is a multi-physics simulations near the wellbore. So that's the basic idea here. Definitely, I'm not touching anything related to IoT, for example, digital twin. So I'm just touching here the traditional areas of oil and gas here. So obviously there is ample scope for anything related to a digital twin. Obviously the digital twin and IoT is going to play a very important role here. And then I'm not talking about anything related to big data here. Once again, all these are already I think that this is something that everybody is talking. So that's a done deal, okay, that I'm going to consider that everyone knows. So that's the reason I just touched upon the areas of, I should say, conventional or traditional area in oil and gas, okay, especially from the perspective of E&P. So if you ask me, where is our pain points? What are different challenges we have? What are these opportunities that this can provide to from the perspective of HPC. So infrastructure-wise, as I mentioned it earlier, we have operations in 34 countries. These 34 countries, each of these locations might need use of HPC. Okay, having our own HPC on-premise is really a challenge there. Especially in countries where we have a lot of inequalities. Having an HPC in the middle of Madrid is not the same as having an HPC somewhere in a country in South America or in Africa. Okay, so that's a big challenge there. So then at the same time, cloud offers a lot of opportunities, but the data transfer is an issue still we have. Okay, and then as I mentioned, inequalities about the geographies. What could be the opportunities here? Definitely reducing this inequalities in geographies. HPC is something that needs to be accessible everywhere in every part of the world. That's a big opportunity, and then cloud can help us a lot there. Okay, and obviously these countries with national infrastructure that needs to be we should have better infrastructure. Now there is an opportunity there. Then I'll just touch something on training. See, this is very important, because we don't have, especially in some of the countries where we operate, the expertise from the perspective of end user. So I was just putting these two on a lighter note, that we have to convince people to use HPC. You see, that's something that you could not even imagine in an academia, but in industry, yes, sometimes you have to say that, why don't you use 128 core? Why don't you use 256 core instead of running on your laptop? So that's the kind of thing. So. And then we have to tell them, using accessing an HPC is not anything, Herculean or difficult task. It is as good as using your smartphone. Everybody understands how to use a smartphone. So the use of HPC should be there. So the training should be focused on this area. And then there is a huge gap, even if you have an infrastructure in some of the areas. Maintenance of this infrastructure is huge gap. So that's where I would say that training needs to be focused on. So what are the opportunities? Opportunities that we have to create awareness. So when you create an awareness, that awareness creates opportunity. And what are the opportunities? Both to improve infrastructure, and then when you improve infrastructure, your research and innovation improves. Okay. So I will touch upon this one. This is a very sensitive subject, and then this is quite important for us, the cost. So as I told, infrastructure and training is a challenge. Then most of the things are centralized, and then we are looking for going to the cloud. So cloud cost is sometimes, I would say, not exaggerating, prohibitively. Cost is quite prohibitive sometimes. In certain configurations, certain architectures, especially in cloud, is quite expensive. Okay, so what are the challenges is that the lowering the cost is a big challenge, and then that creates an opportunity. How this is going to be accessible to wider users, and then when you have more users using the cloud computing, and obviously that will reduce the operating cost, and this less operating cost, that means maybe have more use cases, and then these new use cases will mean that more research and innovation. Okay. I'll just briefly touch upon the technology. Okay, obviously exascale and quantum are challenges, and then I'm not sure. This is just a question that I'm asking myself. Are we at the end of the conventional HPC? This is something I don't know. So this is something that I ask myself. Okay, I have my own doubts. So as an opportunity, I just want to touch here that there is already a business case. I would say I just put the use case because from the perspective of proof of concept, I don't think so. We don't need any proof of concept because we need a business case, real business case. There is quite a lot of business case for the next generation HPC that can be exascale or quantum. Okay, I just mentioned there that if in the opportunities column, different actors that can be, intervene to make these opportunities into realities. Okay, that's it, and then I will end my talk here, and then if you have any questions, please feel free. Thank you very much.
Thank you.
Thank you, Kanta. This is very interesting. I think I'll reserve my questions to the end. So I'll give.
Yeah, we have lots of questions coming in the question panel. So I invite our speakers to look at them and get ready to answer at the end. So thanks to all of those who already asked questions. So now we hand over to SICOS, to Andreas. So Andreas.
Hello. Hi, Pascal.
Now you should be able to share your slides.
Yep, this should work now, I hope.
Perfect. Thank you.
Perfect. Okay, so thank you all for being here. I'm going to look at the topic today from a slightly different perspective. In contrast to Repsol, I'm not a user directly, but my task is, well, to address users, especially SMEs. Just a few sentences about SICOS. We are actually, well, not really a public company, but we are owned by public shareholders, by two universities, University of Stuttgart and Karlsruhe Institute of Technology. And my task is to support industry, especially small and medium-sized enterprises, in taking up HPC and HPDA data analytics. And we also funded by our state ministry in Baden-Württemberg. There's a public-private partnership which we have with Porsche and T-Systems on HPC, let's say for large companies. And we have solution centers where we cooperate with industry. I'll go into that a little bit later. So my foremost challenge is really to facilitate SME access to these systems. So that includes everything addressing them, but also making sure that it's getting easier. But it's not only about providing access or leading them to somebody who can give them access, but it's also to find support or to support them in finding the right partners, because especially SMEs rely a lot on partners, service providers, etc., consultants. And so we have a pretty wide focus with a neutral position there. And on the other side, our computing centers at the two universities, of course, learn a lot from the cooperation with the industry, and it influences also their work internally. And this, we also see this as an optimization in the other direction. So in order to support our SMEs or companies in general, we don't send large companies away. We also talk to them, but it's, let's say, more costly for the smaller ones. We actually try to address everything that's related to using HPC as we are focusing now. So this starts application. We have good relations to the ISVs, for example, software. We support visualization. That's also in-house, for example, at HLRS. And of course, there's the hardware, the infrastructure like networking. So if it's, for example, about fiber installations, we try to push that as well. And then general consulting, even in the direction of business models, etc. That's all we try to provide. And this is there's a basic a little bit. We do projects on our own that support these activities, but we also help SMEs to find funding if there is a need, and we see a good opportunity to do so. So a few words about our solution centers. This is actually, it started 2008. Right now we have 4 solution centers. The 5th one is right in the making. And they are, well, we started with automotive in 2008. Then we had energy coming soon thereafter. There is a smart data solution center, which in contrast to the others is not industry sector related, but technology related. But again, industry sector is media, so it's media and arts we are addressing, and the new one is going to be in the medical field in the health environment. And these solution centers are seen as a bridge between industry and science. They should be institutions for cooperation. So ASCS, for example, is a German association with let's say public interest, and we would like to team up all stakeholders, so to speak, there. And for SMEs, of course, there are special challenges. It's a little bit more difficult for them, but in such a group, it's much easier for them. We also focus on real projects, so there's a lot of cooperation, trying also to get common projects going, either between industry or including industry and research. It's in a pre-competitive environment. So for automotive, we have, for example, Porsche, Daimler, and BMW in the same project. But of course, if they are looking at their tools, they cooperate anyway. So, and HPC in that sense is definitely like a tool. And our focus is really to make the entry into the world of HPC and HPDA as well as easy as possible, simple, flexible, and quick. That's how we notice also, especially SMEs, need this kind of flexible cooperation. But it's not enough, because if you want to have something well used, sustainable, you have to make sure that they are also really able to do that. And there we identified a while ago training as a really important tool. So since 4.5 years almost, we have the MÖBE project. It's funded by the European Social Fund. ZICOS, we are not directly eligible for this funding. We are supported by our local ministry in order to have the relation to industry well represented inside the project. The other partners are universities, Stuttgart, Freiburg, and Ulm. And here we developed a modular training system for HPC experts. So there's a very high need for these experts, but well, there's a lack of them as well. And we are trying to help the companies and also the people to make progress there. And we have developed a modular HPC expert training course. So it's a vocational modular training. We do it blended learning wise, and well, since Corona, it's almost, well, there's no physical meeting anymore. In the beginning, we had usually a meeting, and in the end, so this is also currently virtual, although we are looking forward to going back to the real world next year. And the target group definitely is participants from industry. We have different classifications, like an HPC user, an administrator, or a developer. They have different needs, and we try to address this, so administrators in a sense. And right now we have a set of 7 modules, and we are extending this during the, well, after the end of this year, we'll have this in a commercial setup, headed or it's organized by the HLRS Computing Center. And we are definitely looking forward there. So here just a few well, buzzwords about the courses that we have. So just to show you that we really cover different aspects, even economy and ecology. Well, I admit there's 80% economy and, well, probably 90 and 10% ecology, but still we are addressing these issues. There's also a peek into data analytics, but as I mentioned, a parallel program is definitely nothing for an SME user, but we have participants from companies who develop software and which send new colleagues to us to get them going quicker. We also do something similar in the field of data literacy, data science for SMEs, again, training and qualification. We do this, again, it's an ESF project where our funding comes from our local ministry. And there we have 9 universities eight universities here in Baden-Württemberg teaming up and making their knowledge, their courses available to companies. here's the focus, all kinds of companies. It's more like addressing people wherever they live. So Baden-Württemberg is not really that large, but we noticed that people prefer, at least in a physical environment, drive times be less than 1 or 1.5 hours. So we try to really get this training possibilities into the to stretch it out. And to sum up, to come to the end, the key success factors for successful industry projects we identified. Of course, it's industry. It's all about money. So there must be a short-term financial viability, especially for smaller companies, because they have less of a buffer. The risk they take, they calculate very exactly. They try to minimize their risk. So it's better to have smaller steps with less risk than a larger thing. Of course, industry needs a really stable production environment. On the other side, they want to have a very flexible environment, which somehow in a way also sometimes might contradict. Very important is a good workflow integration, ease of use for those. So I just heard everybody knows how to use a smartphone. Actually, it's a challenge, but we have to think that way to make this also possible for HPC. And of course, as long as it's not so easy, we definitely have to have excellent support. But there's also, let's say, more human-oriented aspect, and that means with our customers, you have to develop a high level of trust because they rely on you, and this takes some time. That's also why we have a long-term perspective, but run, this is definitely the way to go. So that were my impressions on that. Thank you for listening.
Thank you. Yeah. Thank you, Andreas. I think the solution centers was a very powerful concept, I think, in terms of education and training for SMEs to get on board using HPC. Thank you.
So Iris, I've handed over to you. You should be able to share your presentation.
Yes, I put it in full screen. 1 moment.
We can see your screen.
Yes.
With a small presentation. If you can make it big.
It is already in full screen, so it should show it.
Yeah, now it's okay. Thank you.
Yeah.
Okay. Yes, you can see already what we are doing on this first slide. We are doing computational fluid dynamics mainly. My name is Iris Pantle, and I'm coming from a very small company, rather a micro company than a small company, I would say. We are an engineering office. We are a spin-off of the Karlsruhe Institute of Technology. We have background in mechanical engineering. We have background in high-performance computing as well. From the time when we have been staying at the University of Karlsruhe or Karlsruhe Institute of Technology. As for the next slide, you can't see it, I guess. Is this correct? Can you see it?
It takes some time, I noticed. So
it seems so. Yes. Oh, I'm sorry. Yeah. This is who we are. Who's behind our company? When we founded it, we have been 3 people with slightly different expertise. We are all from the Karlsruhe Institute of Technology. I just go to the next slide. Our background is we have been founded in 2014. We are an engineering office. We are specialized in computational fluid dynamics with a particular specialization in computational aeroacoustics. And that formulates the challenge that we face. We usually do CFD on a transitional scale. That means we do large-scale computing, long-lasting computations. With transient information and with a lot of data input, data output to visualize animations and things like that, to analyze things. We have also particular specialization in fluid machinery design, and that is where we find our customers. Currently, we mostly work with the automobile industry, but sometimes also with other industries and do particular machinery designs, usually fluid machinery, such like fans or turbines, things like that. Although we are a relatively small company, we still have some in-house development of code. So we are not only using other people's code, but also have our own codes for specific purposes, particularly for the computational aeroacoustics aspect. And to use that in a very, let's say, handy way, we have in the past developed a platform, a cloud platform, essentially. So whenever I talk about this this terminus Nuberisim, which you can see all over, and which the slides are also named for, Nuberisim is actually a mark which contains two things: one, a platform, and second, a solver. The solver is originating from Karlsruhe Institute of Technology. And it's essentially, it dates back some, let's say, 20 years when the development started. And it has been successively upgraded and further developed. And this solver within that Nuberisim cloud platform actually is HPC ready. So we can use it within our own platform, but to some other part, we use it in the frame of customer projects or in the frame of research projects where we also develop additional modules. We can use it on HPC system, on HPC systems, on classical HPC systems. So I, in the frame of this webinar, I usually distinguish between a cloud system where we have a cloud layer and a management layer, and a classical HPC system where we have access to. We are mainly using in Stuttgart the HLRS for doing high performance computing. We have access to this facility via CCOS, as Andreas Wilse has already spoken, so you know already CCOS. But we also use other facilities. HLRS is a tier 0 facility in Germany, and is relatively easy, close by, and we can use it straightforward. Still, we have some challenges which I come to later on. That's actually what we usually do. Usually, we use a cloud environment when we use it for performance. That means we can use it in an easy way, like on a tablet or on your smartphone with a browser, and you open it, you upload something, you configure your simulations with the graphical user interface, and then you start the simulations and get back some results. That's the main circle. But in a way, on the HPC systems, you don't do it like that. Still, we favor it in some contexts, since as we compare costs here and there, we have some slight cost overhead on the cloud side in comparison to HPCs, to classical HPC systems. So depending on what the customer wants, we also send some calculations to the HPC system. Currently, our main task on the HPC system on HLRS is actually in the context of research projects. So the main things we do currently at the moment there is developing, compiling, putting data for our project partners onto the system so that they can take it, can share it, can use it for their developments in the frame of some collaborative projects. We have currently a large project running, which is also dealing with artificial intelligence in a similar way as Carlo already mentioned. We are also trying to use artificial intelligence for either interpreting results of CFD simulations, or even for the step of grid generation, as well as for a let's say, holistic optimization loop. So that's as part of the publicly funded research projects that we do on the HPC system. We have definitely, that's one of the research projects. Another research project, for example, is addressing CPU, GPU projects. This is something we know that we could use it already on the HPC system. We transferred with our partners to cloud systems to get ready. As it comes to business cases, earlier or later, we need all what we develop here in the frame of research projects at the HLIs. We need to transfer that to a cloud system. So what we do is basically we test, we look for performance, we look for smooth workflows that could be later on transferred to a cloud system, build a graphical user interface for that, and then run it on any system that is possible. As it comes to, let me see, sorry. As it comes to the CFD simulations, if you would like to ask me for what is the impact to our company, it's not so much a direct, let's say, a revenue from user perspective, but it enables us to do large-scale simulation without having HPC systems in-house. Because we are a small company, we are a spin-off of Karlsruhe Institute of Technology, we do not invest in hardware. We have our normal PCs on desk, and we use internet to access the HPC system from remote and have it there and know what we can do there. So we are HPC systems are enabling us to do large-scale simulations. That's very important. 3D, transient, millions of cells, anything what you would like to wish. In comparison to the established resources that we have in-house, we have definitely large excess by using HPC systems, so we can be relatively flexible. We have really powerful resources, and we have regularly upgraded resources. We do not have to care for that. It's clear no advanced investments and maintenance is required from our side. So that's the main impact on our company. We are flexible. We have a cost scheme. Yes, we have to invoice this to our customers, and it's definitely a challenge to make that in a concise way. But still, it is possible, and I think this is a very good, a very good idea to have HPC around and to use it, make use of it as massive as possible. As it comes to challenges, as I have explained, we are always bridging between a cloud system with a cloud management layer and a typical cloud workflow with graphical user interface and so on, and the HPC system. So what makes us trouble from here and there is the holistic workflow management of all these, let's say, components that we have. We have optimized our system actually for cloud. So when we go to the HPC system, then we can use the solver. Okay, we can compile it, that's fine. But we have rather more difficulties in making the graphical user interface run and finding the libraries that we need. We have to make specific issues for the things we develop just to get it run on the HPC system. So that's one aspect where we still always struggle with it. We still face, as long as there are, let's say, updates, or we underwent at HLIs, we underwent a complete system change by January 2020. We had to redo many things to adjust our components of our workflow to the libraries available there, because not everything is there that we usually rely on. So we had to do some workarounds, which is a costly thing, especially for a small company. It takes time, it takes manpower away, and that makes a little bit of a hassle on the whole picture. We have also here and there some issues with the storage management. So you have only limited storage resources, let's say not limited in the sense of amount, but in the sense of time. So you need to up and download data to store it somewhere else to make it available at a later time. And downloading, uploading large results, large simulation cases is always a thing you have to plan in advance. This is a thing we are still struggling. Also in the context of the research projects where we have to make data available to the others, you need always to plan in advance until which time is my data still available, and I have to move it around. That's also a costly thing from a certain perspective. So if you transfer data on typical internet speed, as we are remote, then you have some bottlenecks, definitely. And sometimes it takes a night to download things, if you're lucky, and to upload maybe even more. And yeah, that's kind of a hassle we are challenging. So on a long perspective, it would be interesting for us to have facilities where we could do all part of the workflow that we usually need there on the HPC system. To date, that's not possible on this holistic perspective. It's possible on our cloud system, but it's not possible on a holistic perspective on the HPC system. Yeah, as usually, as like other companies, we have to keep in mind cost monitoring, things like that, but that's rather easy, and it's comparable and competitive to cloud systems. So from that point, it's sometimes an issue. It's a bit more complicated here because we cannot split directly by customers, which we can do on the cloud system. So we have to reallocate the cost to the customers. But it's feasible. It's just a thing to do. What makes us more struggling is that as the others already mentioned, as systems evolve and as we are facing exascale systems, or as we are facing, for example, different technology or techniques like FPGA, we need to, even by doing hybrid computation with GPU, CPU, we need to revamp our solver and need to adjust steps, need to do performance checks. And that's a knowledge we do not easily build up. So that's something where we really rely on external training, on people that can tell us what's the issue, how can we do that, and how easy is it to get codes revamped on issues like that. So that's a task which we foresee in the future, which could cost much of the time that we spend on doing the development, since we need to be ready at certain point for next hardware generations, for new hardware, and for new technology, and that really takes time, and we are not clear at this moment how far we can drive this, and do we have the capacity as a small company to face the challenges that are coming with that. So I think I'm at the end. Thank you for listening, and I'm open for questions.
Great. So thank you, Iris. I think the main takeaway for me was usage of tools and methods to do large-scale simulations, without any in-house HPC systems. I think there's a lot of lessons to learn for SMEs, especially with there's going to be federated HPC infrastructures, and there's HPC in the cloud. So very interesting. Thank you. So I'll hand over to Pascal.
Okay, so we have lots of questions. I'm currently assigning questions to the right person, but are you looking at the questions, Sai? Did you have time to look at the different questions, or do you want me to share the question panel?
Yeah. So yeah, I for some reason I don't see the question on my client on the.
Okay, so I will just share the
Yes,
questions. You know, there
same
is
for
no.
me. Same for me.
I can see the
Oh.
questions.
Or help
That's
us with
because
the
you're a
right
speaker. Okay, so
action.
I don't know why you don't see it.
That's fine. You can share the
But
questions.
I'm sharing
We
them. Can you see them now or no?
no,
It's coming.
not yet.
Not yet. Come on.
Take your
Sorry.
time. That's fine.
Well, it's not working. Okay.
We need HPC.
Yes, especially during these times when everyone is online.
Okay, so I will. Okay, I will try it again. No.
Or perhaps
Okay.
one thing you could
So
do
I
is
will just. Okay, so I'm sorry
cut and
about
paste the
this.
questions. No problem. If you can, if there is cut and paste all the questions in maybe the chat here, then we can take it up one by one, because Jean-Philippe and myself, we have prepared some questions as well. So maybe some of those
Okay, so
questions
we
fall
have
under
lots
that
of questions.
category.
Okay. Let me see. I'm trying to find the best way. Okay. Sorry about this. So should we try them in order?
Yeah.
First we had questions to.
So is it have you where have you provided the questions, Pascal? Is it in the chat?
Yeah, I'm still working on it. I'm sorry about that.
Okay.
I'm
no
supposed
problem. So perhaps one thing I would recommend, as Pascal, you're working on this. So since also we are, it's a time wise, I just want to make sure we address all the things. So as you're gathering those questions, maybe
it seems
maybe Jean.
now. Okay.
So Jean-Philippe and myself can just start off on some of the questions. Hopefully, some of it fall under that category. So you all mentioned about the biggest challenges you're facing at the moment. So thank you for providing that. So I think one main question I think we always have as when we coordinate this inputs from industrial users is, can you just quickly tell us what do you require to better exploit HPC? So you all use HPC in different ways, and is there something that's clearly lacking at the moment in terms of if there is one thing that's lacking, better exploit HPC in the business? So what would that be? So maybe we can just go over around. Jean-Philippe, you can add some color to that question if you like. We can go over. Maybe we can start with Iris. What's your thinking on that? I don't hear you.
Yeah. I'm sorry. Can you repeat shortly the last part, because I'm dealing with the questions here.
So we got the challenges, a bit of a color on the challenges you're facing. If there was one main challenge for you that you want to tell us about in terms of usage of HPC, if there was one, what would that be?
Well, main challenge is definitely that we have to deal with, we have to classically adjust our code, adjust libraries, adjust things, because we have on one hand, I mean, the scenario is like this. We have on one hand a specific setting for the cloud where we define what libraries we need, why do we need them, and how do we compile them, how do we make the ISO image, and so on. We cannot transfer this literally to the HPC system. So we have to set up a specific compilation environment for that, have to put libraries if we need them from external them ourselves. We have to make that they are compatible with the libraries on the system and things like that. That's time consuming. And I have faced my colleague who is doing that as a, in fact, as his main tasks. He's doing that for times, and it's really taking time away. So that's one of our biggest challenges. How do we streamline this? How do we smooth it? How can we rely on the libraries that we find on the HPC system? How frequently are they updated, and so on? So we need to adjust continuously to these things. That's one of the main issues, I guess.
Interesting. Yeah. Thank you, Iris. And as I was about to hand over.
Sai and Jean-Philippe, you should be able to see the questions now. The problem is I can't share the panel.
More or less, it's a tiny panel, just difficult to.
You can make it bigger.
Yes, we can just go over it one after the other. In the interest of time, I think what we could do. So now we can move over to Kanta. So I think I was about to ask the same question, Kanta, but also there is some additional questions from our audience as well. So maybe you can answer that in that context. Sure. So one of the questions was how much has Repsol reduced the time to production for oil and gas? Yeah, please.
I have them here. I'll go to that one. So I would like to apologize in advance. I have a hard stop at 1 p.m. So I really apologize for that one. So coming back to the question, okay, Sai, Jean-Philippe, you're asking about the main challenges. The main challenges, especially for E&P, exploration and production industry, here is accessibility. That means the accessibility to HPC can be, if you look at the accessibility issue, it has got one issue of training, another issue of cost. From the perspective of technology, majority I would say of the industry, especially in exploration production, they are end users. They are not developers, and they usually don't even maintain the infrastructure. So from that perspective, if you look, the main challenge is making these people that there is a tool, and that tool is going to make your life easy, and then it is not, a big monster, and then you can use it easily by minimum training. That's one thing. And then it is not going to cost you a lot. Your bosses are not going to come back and say that you have $500,000 in HPC cost at the end of the year. They are not going to fire you, something like this. So cost and training from the accessibility. Now if that is the challenges, then I'll go to the questions that has been asked. Andreas Soldo has got two questions. One is related to how much Repsol has reduced the time. So something, Andreas, is a great question. The most important, I should say, challenge, that anybody in exploration and production industry is facing is this one: time to first oil. Why this is so important, as you're rightly asking about the savings. Your next question is, what about the savings? Okay, so these both are related. So here is, directly this is time is money here. Why? Imagine that you acquire a block, okay, and zero time, okay, and by the time you have acquired the seismic acquisition, okay, and then by the time you have processed, by the time you have some interpretation, and by the time you have the first petroleum systems are mapped, and then you have the reservoir identified, and then you're going to trace a well, and then you plan for the drilling of the well, you award the contract, and then you drill the well, and you get the first green signal of that you have drilled the well. Probably 4 years have passed. Okay, still remember, you have invested probably between 500-600 million euros already. Okay, and then you're going to say that I want to do another positive well. So second exploration well, and then you have a appraisal well, and then you start the real field development plan, and then you start producing. So that first oil or first gas can happen from 0 to 6. So by the time you have the first oil or first gas, you have 6. I would say probably 1 billion or 700, 800 million. Easily you have already invested. So that money is not generating any revenue for you. Okay, but you are paying the interest for that one. Okay, so HPC alone is not going to cut short this time. So imagine you're cutting short this time from 6 to 10 years to 3 to 5 years. So that 2 years, what you're going to save, that is going to affect your net present value of total investment, and your break even is going to be much lesser. Okay, good. HPC alone is not helping there, because remember that seismic acquisition, okay, processing, imaging, and interpretation, we already use HPC, and this is the time frame we have. Okay, so then HPC alone is not going to help us in this one, but we need to have different layers of reducing the uncertainties. So when you reduce the uncertainty, the process of decision making is going to be much easier. Okay, for that we need to have the complete integration of different technologies, that is the cutting edge technologies right now, in the sense of big data analysis, machine learning, artificial intelligence, combined with the capacity of the HPC. Okay, so as an average, I should say that if you're looking at 6 to 10 years, you should be able to reduce it to 4 to 5 years. Okay, so that's the big challenge goal. Okay, and then savings, just you do a calculation and a 10, 12, 15% interest over 1 billion over 10 years. So you should get the savings there. Good. Next to another question, I have 2 questions from Alexander Hector. So can you elaborate on challenge of this data transfer? Iris explained very clearly. I don't think so I need to go any further for uploading and downloading. I just have to say that a typical small survey of geophysical data can weigh up to 400, 500 GB very easily. Sometimes it can go. Remember that you're going to generate several dozens of volumes out of this one. So you multiply by this 200, 300 GB by 30 or 40. That's the volume you're looking at just from the perspective of geophysics. I don't have to say that if you're looking at a digital twin and then you have 20 wells running and then different distribution system, gathering systems, and then platform, all those things, even if you take one data sample per 10 seconds or 1 minute, that's huge. Okay, so it's I can give you more example on that. You have my contact and I can elaborate on that one. So would you benefit from commercial HPC training? Obviously, absolutely. The commercial HPC training is not from developer perspective. Commercial training is from end user perspective, okay, and then maintenance of the hardware perspective. Finally, I have a question from Lilith Axner. Data security, okay, and then look, I should say this. This is very interesting. Oil and gas companies are paranoid, just to say, for data security. So we have the utmost, data security, because our data is our money. Okay, so you don't have a positive well, without that seismic data that what you have, and then afterwards all the interpretation and everything. So data security is utmost important, and then confidentiality. You're not working alone. None of these oil companies in any of the blocks, they are not working alone. So they have partners. So you have to make sure that you are not using any of these freely available HPC systems. We cannot even use for a production environment. As I told, Barcelona Supercomputing Center is our main R&D partner. So it is not the production or HPC partner. HPC, we get HPC from other vendors, So Barcelona Supercomputing Center allows us to develop new technologies, tools, cutting edge technologies, but for running our production environment, we need to have a very secure environment, and that has to be not only approved by Repsol, because you need to have all the approval and security measures from your partners. I think that would answer most of the questions. That's what the questions I have. Yeah, thank you.
Thank you, Kanta. I think people can always get in touch with Kanta for more deeper, discussion. So I think maybe we can go to Carlo now. I think Carlo, there's a question for you, and also there's a general overarching question about your main challenges that you face as Leonardo. So if you can just give us some insight on it, that would be great, Carlo.
Sorry, can you repeat the question?
Yeah,
Yes, so
JP speaking. This is a question. If you can read them now on the screen, thanks, Pascal. It's easier to read there. There is a question from Sabri Plana for you regarding neural network ODE, and he would be interested in more illustration of this aspect you've mentioned, maybe briefly, and real-world examples from your experience.
Okay. No, just a project that is starting. Okay, and yeah, this is just an example. It's not only about one-dimensional partial differential equation that we intended to solve the problem of trustability. We have also other technique, but for sure this is something that have been started to be investigated by a colleague, which is ongoing, and we will try to assess it thanks to the HPC. Not that for this particular problem we need an HPC infrastructure as large as we have, but for sure it will help a lot to have the possibility to run concurrently from one side the solution of the equation, from the other side the artificial intelligence model. But this is not the only one. We are investigating other mathematical tools in order to let's say guarantee that the outcome of a given neural network is guaranteed that it falls within a certain range of value, because this is what the certification authority asks for. So just because they don't want, an example, that an helicopter immediately, just because you have installed a box, take a maneuver that something.
So we lost you for a second, Carlo.
Carlo, we've lost you.
Okay, there was a problem on the connection. So just because actually, if you want to, we have recently seen the experience of the Boeing 737 MAX, if I've reported correctly, which where the software behavior has caused a big trouble to the company. So we would like to avoid this kind of situation, especially if you are starting to install a component that are based on artificial intelligence, because we think that for tomorrow a lot of what now is done by a pilot on a fighter plane or an helicopter will be done by artificial intelligence modules that can react promptly and does not suffer usually from let's say the condition, the stress condition a pilot may face in a critical and dangerous situation. So for that reason, it's important to certify this component to support the piloting.
Great, thank you, Carlo. And we can just move to Andreas in that case. So Andreas, there's I think there is one question for you.
Yep.
So what is? Okay, so if you can answer that and also just tell us a bit about your biggest challenge you're facing, so that would be great.
Right. So in general, we are, let's say, 50-50 HPC and data analytics AI oriented. Right now, the focus is a little bit stronger on the AI HPDA side, because we have, this is also related to research, or well, not research, to project funding, where we can support the smaller companies better. So we have a long running, one of the solution centers, the Smart Data Solution Centers, that helps us a lot. In general, on the HPC side, we have mostly engineering background, so there's a lot of CFD because it scales pretty well. So not really a lot of bio. We are extending our fingers a little bit. I mentioned medical, it's not the same, but we are trying to reach out there as well. And really AI usage, strong AI usage, that's going to grow. Right now, we are more talking to SMEs to help them get on board with that. So which is actually a little bit different on HPC. There we already have a lot of really active users there.
Got it. Thank you. And I think Iris, there was some more question for you as well. Hopefully you can see the question, Iris.
Yeah, I've seen the question. Yes.
So explaining the detail of it. Yeah, go ahead, please.
It's about the question of the storage management that I mentioned, and if this is a bandwidth problem. It's a couple of scenarios which need to be addressed here. First of all, if we easily can create a terabyte of data for one customer case, and this data needs to be analyzed, needs to be transferred to us for analyzation, and sometimes even to the customer for analyzation. Now the scenario is we are not within the HPC center, we are not located there. So we have some kind of, first, depending on the location, bandwidth problem. For example, we have customers which have a very low bandwidth. Ours is moderately good. So we have different locations where we deal with and where this may take some time. And in some cases, we really take a hard drive and go there physically to, and not to the HPC center, but to our customer to deliver it. That's one thing. It would be in a way nice to have there a central access facility where we can store and where we can exchange data. That's one thing. Then the other thing is visualization. We need to analyze things, and we need some special visualizer. You know that if you do CFD. And you need to treat some large data sets to have transient analysis on, or to have to where you can analyze your transient data sets. And that takes time. And it is, in fact, it would be beneficial if we could do that on the HPC system directly. That's not always possible. And in that case, we have to download it as well and have the same bandwidth issue. Now, we have a couple of scenarios like that. And we control a simulation throughout its run. And we have some, let's say, regular write-outs, which we control also. We have to download these, things like that. So the bandwidth issue, there's a suggestion how it could be solved, for example, by renting out HPC systems locally to us. That's not a scenario which I would wish, because we're a small company. We need to have the facilities to have some kind of servers running. No, forget it. And we even would create some other security issues, where to put it, how to close it, things like that. That's not a scenario that I would wish to have. I would rather prefer that we could deploy the whole workflow that we need to perform for analyzing the customer cases, for running the customer cases, for configuring the customer cases on the remote system. And in a way, we have created a system how to do that on cloud. So we can do it there. We can do everything there. We can even do some visualization with some smart rendering via browser access. That's already in a way possible, some better, some less. but still it's already possible in a way, but it's not so much possible on the HPC system. So the idea behind is rather than renting some HPC systems without a bandwidth problem, rather have facilities which we can connect and can do all the workflow put together on the HPC system.
This is Carlo. Sorry. May I comment?
Sure, go ahead, please.
Yeah. So, well, my experience and actually what we are planning is that when you start to grow in terms of size of the data lake of the the data of the physical model, when you are above 1 terabyte, let's say, so maybe 10, 20, 100 terabyte, so the data cannot be moved at the end. So, so we are planning actually to do everything inside the same infrastructure and providing remotely the capability to visualize and analyze the data. This is challenging, as has been said, but actually this is the only way, especially if you have also security problem, not only bandwidth problem, because in many services we are running, so these are in context and situation where you cannot have a safe connection, let's say. So everything will be done consolidating the data into a cloud-like environment together with the HPC. So we will provision the same sort of storage and the compute capability in two ways. From one side, batch-like access, okay, traditional one with remote desktop, and in the other case, building microservices or building, let's say, application on top of a cloud stack that can see the same data lakes to have everything all together. Then we have also the need to collect data, and for that particular purpose, we are thinking also of empowering the edge component of our product. Suppose that we deploy a control room for a smart cities or an airport, and there we cannot obviously bring all the data to a central facility, but there can be an edge like device or setup that can locally provide data reduction and data analysis that has been trained on the central facility. So this is more or less what we see. So data, especially large data, will be difficult to be moved outside, okay, to the periphery. So to the periphery, you can collect and process data, but difficulty, you can move the data back to the periphery. You can return back as services, but data is much more difficult.
Yeah, may I add one small thought to this as well?
Absolutely. Please.
One scenario in our house is that we are working with the same customer for some years, and from time to time the same case pops up. Let's say in 2020, a customer case popped up that we have treated already in 2015, and we should be developed further. So we are usually not throwing away the data as long as we work with these customers. As long as we have a contract with them, we keep the data. And that's also an issue, or maybe a service which we even would be ready to buy and to budget into our bills.
Well, I encourage you to do so. Provide also the curation service for the customer. I think this is can be a good idea in this case.
Yeah. Yes.
Yeah. Thank you, Iris. And I just say that we are slightly above the hour, so I think unfortunately we are out of time for further questions today. But by all means, I think the audience can get in touch with the panelists. So Pascal, I think it's back to you then for any final comments and any final words.
Yes, thank you very much to all of you for being with us today. I think it was a very interesting exchange. I will go through the questions and make sure that we've answered all of them. I think we have, but I'm storing them and checking anyway. If you will all receive a link to the recording of today's webinar, and if you have any questions about the webinar, you can email us at webinar@etp4HPC office.eu. The email is in your invitation, and so you will find it very easily. Next webinar is on 15th December, so remember to register now to save the date in your agenda. And yeah, that's about it for me. Thank you again to all the speakers who spent time with us. That was really interesting. We rarely have testimonies from such diverse speakers.
Jean-Philippe speaking. Maybe last one. Thanks again, Pascal, and thanks to all the speakers. It was very, very interesting. Maybe one of the nicest webinars we've had.
Well, it was the one with the most attendees,
Sorry,
with the highest number of attendees.
Yes, and I had some connectivity problems at some point, but never mind. I think in early 21, we should consider organizing another webinar with the same kind of scope, because it's such a wide and important topic. So again, with TIVE and the Industrial User Working Group of the ETP, we should consider maybe during Q1 of 21 having an extra webinar to follow up on this kind of questions with other speakers, other members of the ETP. That would be my suggestion.
Absolutely, Jean-Philippe. You're very much bang on target. So we will definitely discuss this internally. Thank you, everyone.
Bye.
Thank you, everyone. Bye-bye. And we hope to talk to you again in December. Many thanks to the speakers.
Thanks, Pascal.